my dear students, class 10. I welcome you all to our channel Mind Mapping. Let's recall, we discussed in our last session that image formation by spherical mirrors, both concave mirror and convex mirror. Today we shall discuss Snell's law and the laws of refraction. Okay? You know, light travels in a straight line in a given medium, in a definite medium. Okay. But what happens when a light ray enters from one medium to another? What happens? Let's discuss through an activity that has been explained in your textbook. Let's start. You see, A, B, C, D is a rectangular glass slab. Means it is a 3D object, its length and the breadth and height. Okay. So it is a 3D object. So let us place this glass slab, rectangular glass slab on a cardboard. Okay. Let us take 4 equal size of hairpin. Okay. Now let us fix E and F 2 points, 2 pins, means obliquely or tangentially, okay, and join the 2 points so that the 2 points means joins O or points at O or falls at O, that is called interface. So interface on the side AB, on the side of the rectangular glass of AB. So O is the interface on AB. Now let us look at the image formed on the opposite side. On the opposite side of the rectangular glass slab. So let us affix 2 pins G and H according to their image positions. Now remove the glass slab. So let us join EF. So it falls at O, that is the interface on AB. Similarly, GH falls on O dash, that is called interface on DC, on the side DC of the rectangular glass slab. Now let us join O and O dash, this line. Now ABCD glass slab is removed. Now our observation. And at point O, that is interface, point O, let us draw a perpendicular that we call normal M dash. Similarly, M and M dash, a perpendicular, let us draw on point at point O dash. Not clear. So let us see, this is air medium, we call it M1. So air is the rare medium or lighter medium, and the glass slab, the denser medium or a thick medium compared to that air. It is thicker. So we call it denser medium. So what happens? You see EF, that we have mentioned here. EF is called incident ray. Okay. The incident ray falls at O, that is the interface. And from O, what do we observe here? Let us connect O and O dash. Now it changes its path. It has changed its path. It is the normal path. It is the normal path. From the normal path, it deviates. Means it has come closer to the normal N dash. So the incident ray, and this is the actual path, but it is deviated, means it has come closer to the normal. Similarly, you see, and this ray is called O dash, we have mentioned here, the refracted ray. This is the movement or direction of ray in the rare medium, but this is the movement of light ray in a denser medium. So OA dash is called refracted ray. Now let us see at the point interface O dash on the side DC what happens. Now a ray has emerged, that is GS. So a ray has been released, has been emerged. So GS is called emergent ray from the point of interface, that is O dash on the side DC. So we have mentioned here GS, the emergent ray. So incident ray, and this is refracted ray, and this is emergent ray. And AN dash is the normal drawn at point O, that is the interface on side AB. Similarly, AM dash is the normal or perpendicular drawn at the point O dash, that is on the side BC. Now see what happens. You see the incident ray and the normal. Here is the question. The normal is not deviated. The perpendicular line and the perpendicular ray is not refracted. It doesn't change its path. Okay? And you see the incident ray and the perpendicular ray normal, they form an angle that is called angle of incidence. Okay? That is called angle of incidence, we have mentioned here. Angle of incidence denoted by the symbol I1. Okay? The incidence, angle of incidence number 1. Now you see here the angle formed by the normal and the refracted ray, that is called angle of refraction denoted by symbol R1, we have mentioned here, angle of refraction. Okay. Similarly, you see at this point, point means O dash, that is point of interface, that the normal and the refracted ray, they form an angle. That is also called now angle of incidence, that is I2, denoted by I2. But here angle of refraction, that is denoted as R1. Now you see the GS is the emergent ray, and that is actually O dash, M, that is the normal, or M dash normal, they form an angle. This is called angle of refraction, that is denoted by R2. Now we got I1, I2, R1 and R2. What's the relationship? Now let us compare, we have mentioned here. And this question was asked in your previous year's exam. And in several exams, this question has been asked. Now you see, this I1, this angle is equal to R2. So you see, angle of incidence is equal to the angle of refraction number 2. Then angle of incidence number 2, this is equal to R1. Just actually they are opposite, they are equal to that opposite angle. For that reason, you see the emergent ray and appears to, the emergent ray is not appears, the emergent ray appears to the actual path. If it is the actual path, it is parallel to the incident ray. So the emergent ray is parallel to the incident ray. Let's prove it using this. Now you see, to two perpendiculars that are parallel. That is n dash is parallel to m dash. And you see O dash the transverse. Now you see this is R1 is equal to I2, R1 is equal to I2 because alternative interior angles are equal. That you have learned in mathematics. Now you see, so I1, this angle is equal to this one, this is called vertically opposite angle. But actually, you see, so you see, two parallel lines. So this angle is equal to this angle, that is called alternative interior angle. This angle is equal to this angle. And this angle is equal to this angle, corresponding pair of angles when two parallel lines intersected by transverse. And this angle is equal to this angle, this is a vertically opposite angle. And this angle is equal to this angle, vertically opposite angle. And now we prove this angle is equal to this angle. So as per our logic, so angle I is equal to angle R. So this angle I is equal to angle R. Angle I1 means angle of incidence is equal to the angle of refraction number 2. Just opposite angles are equal. For that reason, you see, the emergent ray is parallel to the incident ray. That question was asked. But another condition you see, so this angle, the measure of this angle, the angle of incidence is always greater than 0 and less than 90. And you know sin 0 is 0 and sin 90 is 1. So in between that. Why? Because the measure of this angle depends upon two sides, that is perpendicular and hypotenuse. P by x, you know sin theta is equal to P by x. So the ratio of the perpendicular and hypotenuse is the sine of that angle. Now come to our conclusion, what we observe here. So two things we have to discuss: Snell's law and the laws of refraction. Now you see, let us discuss the laws of refraction. So what's our observation from this activity, from this experiment that we have done here? The light travels in a straight line in a given medium, that is air medium. But when it enters a denser medium, that is glass slab, it bends, light comes closer to the normal. Now you compare the two angles, angle of incidence and angle of refraction. And naturally it appears that the angle of refraction is less than the angle of incidence. Similarly, you see here, angle of incidence is less than the angle of refraction, just vice versa. Okay. Now you see, so laws of refraction, it clearly indicates that light rays changes its path when it enters from one medium to another. Maybe if you see, in a rare medium to denser medium comes closer. From denser medium to rare medium, it goes away from the normal. If it goes away from the normal, it increases. The angle of refraction increases. So this is the basic of our law. Then you see EF, the incident ray, and O dash, that is refracted ray, and N dash. Then N dash, that is called the normal or perpendicular. All three, they lie in the same plane. You see, the incident ray, the refracted ray, and the normal drawn to the point of interface. all lie in the same plane. That is the first law. The second law that refers to the Snell's law. What is that? The sign of angle incidence, the ratio of sign of angle incidence and the angle residence, their means their comparison, okay, their ratio, the ratio of sin I, angle of incidence, and sin R, angle of refraction, is always a constant. For what? For a given pair of media. Now it is air and it is glass. It is constant. And if it is water and glass, then it will otherwise. If any other transparent medium, it will be otherwise. Maybe glycerin, maybe kerosene. Okay. So sin I by sin R is a constant for a given pair of media. Media means two, that is plural of medium. So rare medium and mixed medium. And a given color of light. And thus for this constant varies when M1, M2 varies, or medium 1, medium 2 are different, and color of light is also different. So sin I and sin R is always a constant for a given pair of media and a given color of light. Okay. So that constant indicates the speed of light in two different media, and that constant scientifically called a refractive index of medium 2, that is M2, with regard to or with respect to medium number 1. That we shall discuss. So this is called a refractive index of glass slab to air. Here the constant is meter decile, that is refractive index, means this constant indicates the speed of light, with respect to, that is air. In air, the speed of light is more, considerably more than that. That's why now the refracted ray has bent, has come closer to the normal. Okay. So we have described here glass to air. Here air to glass, you see the angle is less, means the refracted ray has come closer. From denser medium to rare medium, here you see the angle of refraction is greater because the speed of light is less in the glass slab and it is more in air. Now it is the refracted ray is deviated, is away from the normal. Okay, and the condition is that the angle of incidence and angle of incidence and angle of refraction, or angle of incidence, angle of refraction, should be in the range that is greater than 0 degree and less than 9 degree. This is called Snell's law. So Snell's law is a part of that laws of refraction. So there are two laws, and you have to record it, you have to note it, you have to copy it. The two laws of reflection. First one is incident ray, the refracted ray, and the normal drawn to the point of interface. All three lie in the same plane. Then second, the the ratio of sin I and sin R is a constant for a given pair of media, and a given color of light. There are two laws of reflection that we observe from our activity that has been displayed. Hope you have understood the concept of Snell's law and laws of refraction. So we shall apply this law or laws of refraction in laws of refraction by our lens, means concave lens and convex lens. Okay. So we shall discuss under the refractive index of different media. The different media refractive index we shall consider, and we shall discuss the absolute refractive index, the ultimate level of refractive index. In our next video, we shall discuss refractive index and absolute refractive index. Thank you for watching. Stay tuned to watch our next video. Please remember, after the chapter is over, we shall present some trick-based question or case-based questions or some application-based questions that are possible for your forthcoming examinations. From any other examination point of view, these questions are relevant, may be useful. Thank you all.